In this problem, we have to evaluate this definite integral. We're going to do it by making a u-substitution so we can get rid of this negative x squared. So we'll start by letting u be equal to negative x squared. Now we're going to find du. And the reason we did this, by the way, is because our du is going to be negative 2x. And so you see you have an x here. So it's a good first choice. So du is equal to, via the power rule, just take the derivative, negative 2x dx. So now our goal is to make this here look like our integrand. So we have this extra negative 2 here, so we have to get rid of it. So to get rid of it, we'll just divide both sides by negative 2 like this. This goes away. So we end up with negative 1/2 du, and that's equal to x dx. All right, so you see x dx is negative 1/2 du. So let's go ahead and make that substitution. So negative 1/2 integral sign du. So all we've replaced so far is the x and the dx. Okay, what about this? This is just 2, and then this piece here is u. So all that's left now are the limits of integration. So I'm going to do those over here on the left. You see, these are x values. We need to be dealing with u values because we've changed everything to u. So what we're going to do is use this. So when x is 1, let's do the lower limit of integration, u is equal to, so you just plug it into this here. So it'll be negative 1 squared, which is negative 1. So the lower limit becomes negative 1. Let's do the upper limit. So when x is the square root of 2, u is equal to negative square root of 2 squared. Okay, so you square the square root of 2, you just get 2, so it's negative 2. So that's going to go there. All right, so now we integrate this. The formula to integrate something like this, if you have the integral of, say, a to the x dx, the formula says you just get a to the x over the natural log of a plus c. So here it'll be negative 1/2. A is 2, so it's 2 to the u over the natural log of 2. But this is a definite integral, so we don't need the plus c. So we just put a bracket and enter, or write down rather, our limits of integration like that. All right, let's keep going. So now we plug in the top number first. So this is negative 1/2. I'm going to leave that outside. So we get 2 to the negative 2 over the natural log of 2 minus, and then you plug in the bottom number, 2 to the negative 1 over the natural log of 2. Let's keep going. Let's see if we can clean this up just a little bit. We have the negative 1/2 on the outside. I'm going to put a bracket here. Okay, so this 2 to the negative 2, I'm going to skip some steps here. This is going to come down and become 1 over 2 squared, and that's 1 over 4. So we can write this as 1 over ln 2, 1 over 4, minus, this would be 1 over ln 2, 1 over 2. And I'd like to perform the subtraction here. So what I'm going to do is I'm going to multiply this by 2 over 2. So we end up with, watch this, negative 1/2. It's pretty clever, I think. It'll be, write it like this, 1 over 4 ln 2 minus, and then look at this, 2 times 1 is 2, and then 2 times 2 is 4, so 4 ln 2. Maybe I didn't do that the cleanest way, but my goal was to get an LCD, right? 4 ln 4. We had 2 ln 2, so I multiplied by 2 over 2 to get the 4, okay? And then now we can subtract the numerators because the denominators are the same. This is negative 1/2. 1 minus 2 is negative 1. So you get 4 ln 2 like this. Right, 1 minus 2 is negative 1. Negative and negative is positive. We can multiply across the bottom. So we get 1 over 8 natural log of 2. What a beautiful simplification. I hope this video has been helpful to someone in the world. Good luck.